Assalamu alaikum. Today we will continue chapter 8 about mechanical energy, part 3. Before we start, please prepare your stuff and follow these instructions. At the end of this video, you will be able to give examples of objects having elastic potential energy. Recognize that mechanical energy of a body is the sum of its kinetic energy and its potential energy. Last time we talked about potential energy. We said that potential energy is the stored one. It's divided into two parts: gravitational, which is the stored energy in an object due to its vertical position, which means the height. We can calculate it by multiplying the mass, gravity, and height. And we said that the mass and height are directly proportional, which means if they are increasing, the gravitational potential energy will increase, and vice versa. The elastic potential energy, it's the energy stored in object that can be stretched or compressed. Let's watch this video about elastic potential energy.
Elastic potential energy is the energy that is stored in elastic materials and objects such as springs and rubber bands. If we compress a spring, the force we apply to it will be stored in the spring as elastic potential energy. Once we move our hand, the stored energy will be released, helping the spring bounce back and return to its original position. We can observe a similar phenomenon when we stretch a spring. The stored elastic potential energy will help it restore its original position once we release it. A stretched rubber band also acquires elastic potential energy. The further it is stretched, the more potential energy it has. Let's look at a bow and arrow. When the string of the bow is pulled, the bow, which is made of a flexible material, will bend and store energy. Once the string is released, the energy will also be released, launching the arrow. The further back the string is pulled, the more the bow will bend, allowing the arrow to travel even further once the string is released.
Please open your booklet on Worksheet 12. Observe the following figures, then answer the questions below. Look at this gun. Look here how the bullet is being released. Let's see. Here, in this case, the spring is released, it's not compressed, while, observe here how is it compressed. When the spring is released, the bullet is released, while when the spring is compressed, the bullet is not released. Look here, when the spring is released, the bullet is released. So, describe the aspect of the spring in figure 1 and figure 2. Compressed or not? Let's see. What is the aspect of the spring in this case? What do you think? What we said here? It is, look how it is compressed. While that in figure 2, it is released. So here it is released. As we are seeing here, it is released. And then here in figure 1, it is compressed as we see here. So, the spring in figure 1 is compressed, while in figure 2, it is not compressed, it is released. Number 2, the spring in figure 1 possesses a type of energy. Referring to figure 2, how can we explain its existence? How can we explain the existence of this energy? In figure 1, the spring was compressed. This compressing in figure 2, the released spring led to releasing of the dart or of the bullet. So it did a work. This work comes from the compressing of the spring at the first here in figure 1. So The spring in figure 2 does work by releasing the dart or the bullet in this case. Then it was storing energy in the first case in figure 1. So due to the storing of energy here, the spring performed a work in figure 2. As we see here, when we compress the spring, it stores energy. So it uses this stored energy to release the dart or the bullet. What do we call this type in figure 1? This type of energy is potential energy, but the potential energy is of two types. Here we have a spring, so it is the elastic potential energy because we have a spring. Where does it come from? It comes from the compressing of the spring. The compressing of the spring leads to storing of elastic potential energy. The energy in figure 1 is transformed to another type in figure 2. Indicate the type in figure 2, justify the answer. The dart here is moving, so the elastic potential energy is transformed into kinetic potential energy, because kinetic potential energy is the energy of movement. The elastic potential energy in figure 1 is transformed to kinetic energy in figure 2 since the dart moves in figure 2. Mechanical energy. What is mechanical energy? The mechanical energy of a body, it is the sum of its kinetic energy and its potential energy. In other words, the mechanical energy equal to potential energy plus kinetic energy. Let's practice typical exercise. A cart of mass m equal 100 kg is released from position A with an initial speed of 30 meters per second. The designer of the roller coaster, the black trajectory, wants the cart to come to a complete stop at point B. Neglect friction force. Let's see. Verify that the kinetic energy of the cart at position A is 45,000 joules. Okay, let's calculate the kinetic energy. The kinetic energy equal to half mass multiplied with speed to the power 2. So we have half multiplied with 100 kilograms multiplied with 30 meters per second to the power 2. So the answer will be 45,000 joules. Determine the potential energy of the cart at point A, then deduce its mechanical energy at this position, given that gravity equal 10 Newton per kilogram. Of course, starting with the formula, potential energy will be equal to weight multiplied with height, okay, or mass multiplied with gravity multiplied with height. Mass is equal to 100 kilogram, gravity 10 Newton per kilogram, and the height is 120 meters. Now the mechanical energy is equal to potential energy plus kinetic energy, so we add the values that we have. The value of potential energy and the value of kinetic energy. Of course, don't forget the unit, which is always joule. The potential energy of the cart at point C is 0 joule. Justify why. Since at point C, it is the reference of the gravitational potential energy. In other words, the gravitational potential energy is equal to mass multiplied with gravity multiplied with height. At point C, height is equal to 0. So the gravitational potential energy is equal to 0. Determine the kinetic energy of the cart relative to a person in it. The kinetic energy will be equal to 0. Why? Because since the cart is at rest, V equal to 0 relative to a person in it. Choose from the graph below the one that shows the variation of the potential energy of the cart as it passes from point K to B. Justify the answer. If we observe here, point B is at height x and point K is here. So from K to B, the height increases and gravitational potential energy is directly proportional to height. So the gravitational potential energy will increases with the increase of height. So this graph shows the gravitational potential energy between K and B. Let's sum up. Elastic potential energy, it's energy stored in object that can be stretched or compressed. The more an object can be stretched or compressed, the more elastic potential energy it has. Here we have compressed spring, here we have released or stretched spring. The mechanical energy of a body is the sum of its kinetic energy and its potential energy. Mechanical energy equal potential energy plus kinetic energy. Having two factors, we can calculate the third one. Please study the summary, the typical exercise, and worksheet 12. Stay safe.